Ever wish you could teach a computer to, like understand the meaning behind words, not just memorize phrases?
Yeah.
That's what we're diving into today
Right.
with Attention is All You Need,
Right.
a paper from Google that kind of revolutionized machine translation and AI itself.
Yeah.
So we're going to unpack the core concepts of the transformer model, see why it's so impactful,
Yeah.
and leave you with some thought-provoking questions about the future of AI.
It definitely is thought-provoking.
Yeah.
This paper really did change everything.
So before we get into the after, can you kind of paint a picture for our listener?
Sure.
What was the before? Like for something like machine translation.
Well, the go-to tools were recurrent neural networks, or RNNs.
Okay.
Imagine teaching a computer to translate English to French by feeding it sentences word by word.
So like reading a sentence out loud, one word at a time.
Exactly.
Oh.
And that was the problem.
Okay.
Human language isn't always that linear.
Right.
We make connections between words that are far apart, and RNNs had a short-term memory problem. It was like they'd forget the beginning of a sentence by the time they reached the end.
Oh, wow. So if you're translating something complex, the meaning could get lost?
Precisely. Plus, RNNs were computationally expensive.
Okay.
Processing everything step by step takes time.
Makes sense.
Yeah.
And then came the transformer sweeping in to save the day.
You could say that.
Okay.
This 2017 paper essentially said, what if we ditch the whole sequential thing and let the model look at all the words at once?
Wow.
Enter self-attention.
Okay, break down self-attention for us,
Yeah.
because that sounds pretty powerful.
It is. Imagine each word in a sentence looking at all the other words,
Okay.
figuring out how they relate. It's like each word is asking, who am I most connected to in this sentence? Who gives me the most context?
Okay, so instead of going word by word, the model grasps the whole sentence at once.
Great analogy.
Thanks.
This solves the problems we talked about with RNNs.
Okay.
You get a richer understanding because you're capturing those long-range dependencies.
Yes.
And it's lightning fast because you can process everything in parallel.
No wonder this was a big deal.
Yeah.
The paper also mentions multi-head attention. Is that like self-attention on steroids?
I like that.
Okay.
It's like having multiple experts analyze the same sentence.
Okay.
One focuses on the subject, another on the verb, another on the object.
Yeah.
Then they combine their insights for a deeper understanding.
So it's getting even more context from all those different angles.
Exactly.
The paper actually shows visualizations of these attention patterns, right?
Yes.
So we can see which parts of the sentence the model is focusing on.
Like peeking into the AI's thought process.
Cool.
In one example, they show the model correctly identifying a connection between two words separated by many others.
Okay, so it's clever,
Yeah.
but how much better did the transformer actually perform?
Well, on a standard English to German translation test,
Okay.
their big transformer scored a 28.4.
Okay.
That's called a BLEU score,
Right.
which was a huge improvement over the previous best. To give you an idea, a jump of even half a point is considered significant. So 2 points is massive.
Wow.
And get this, it did that in just 3.5 days of training.
So not only is it more accurate, but it's also faster to train? This is sounding like a revolution.
It was.
Yeah.
Before this, people thought you needed recurrence to handle language.
Right.
This paper turned that on its head,
Mm.
and the impacts goes way beyond just better translations.
This already seems like a big deal, but I'm wondering where else this attention idea could lead.
Yeah, it's like they invented a new kind of Lego brick, and everyone
Mm.
started using it to build even more amazing things.
Yeah.
Models like BERT,
Right.
which helps power Google search,
Yeah, yeah.
and GPT-3,
Yes.
which can write stories and even code,
Yeah.
are all built on this transformer foundation.
So this really wasn't just about better translations. It opened up a whole new way of thinking about AI and language.
Exactly.
Did the paper look at any other uses besides translation?
Yes. They also applied the transformer to English constituency parsing.
Okay. Remind me what that is again?
It's like diagramming a sentence,
Right.
breaking down its grammatical structure.
Okay.
This is really tough because the output can be much longer than the input and has lots of rules.
So not exactly a walk in the park for an AI.
Right. But even here, the transformer did remarkably well.
I'm sensing a theme here.
Yeah.
Transformers good at pretty much everything.
It seems that way. What's really exciting is that this was just the beginning.
Yeah.
This paper ignited a ton of research, and we're still figuring out what's possible with these attention-based models.
Yeah, I'm ready to go deeper.
Okay.
We've talked about self-attention conceptually,
Right.
but how does it actually work under the hood?
It all starts with something called embeddings.
Okay.
Each word is represented by a vector,
Okay.
which is basically a list of numbers that capture its meaning.
So it's like a numerical fingerprint for each word.
Exactly.
Yeah.
These fingerprints let the model compare words and see how similar or different they are in meaning.
Okay. So we've got our word embeddings. What happens next?
This is where the magic of self-attention comes in.
Okay.
For each word, the model creates 3 new vectors:
Okay.
a query vector,
Okay.
a key vector,
Okay.
and a value vector.
Wait, 3 more vectors? This is starting to sound complicated.
Think of it like a matchmaking system.
Okay.
The query vector is like a word's dating profile, saying, this is what I'm looking for.
Okay.
The key vectors are like profiles of all the other words, saying, this is what I have to offer.
Okay. I'm following so far. And what about the value vector?
That's the information the word contributes to the understanding of the whole sentence.
I'm intrigued. So how do these vectors actually figure out the relationship between words?
The model calculates a compatibility score between each word's query vector and all the other words' key vectors. It's like checking how well each word's dating profile matches up with the others.
So higher compatibility score means stronger connection.
You got it.
Okay.
And these scores are converted into probabilities.
Probabilities. So it's not just saying these 2 words are connected. It's saying there's a 75% chance they're related this way, 20% chance that way, and so on.
Exactly. It's capturing the nuances of language,
Wow.
just like we do.
This is really making me rethink how AI can process language. So if each word is looking at all the others and getting these probabilities, what happens next?
Those probabilities are used to combine the value vectors of all the words.
Okay.
Imagine each word gets to speak, but some get a louder microphone based on how relevant they are.
So it's a weighted average of all the words' values based on those attention scores.
Spot on. And that average becomes a new representation of the word,
Okay.
now enriched with context from the entire sentence.
It's like each word gets to look around and see how it fits into the big picture.
And that's the key.
Yeah.
By allowing words to attend to each other directly,
Right.
the model can't capture those long-range dependencies that were so difficult before.
I'm starting to appreciate the elegance of this whole attention is all you need idea. Simple yet so powerful.
And remember, this is just one part of it. We talked about multi-head attention before,
Right.
which adds another layer of sophistication.
Right. Those multiple sets of experts analyzing the sentence from different angles. But that's probably a topic for another deep dive.
Agreed.
Yeah.
But the takeaway here is that self-attention is a real game changer.
Okay.
It drives the transformer and all the incredible language models we've seen since.
It's amazing how something that seems so abstract, like calculating relationships between words, can have such a huge impact.
Yeah, it really shows how much is happening beneath the surface when AI processes language.
Yeah,
It's not just about the words themselves, it's about the intricate web of relationships between them.
exactly. And that's what the transformer, with its self-attention mechanism, captures so brilliantly.
Thinking back to the paper itself, it primarily focused on machine translation.
Right.
Did the authors realize what a big impact this would have beyond just translation?
They definitely hinted at it. They talked about the transformer's potential for tasks like parsing.
And how important it was to make AI generation less sequential.
So they were already thinking about the bigger picture. Speaking of which, you mentioned earlier that the transformer's impact extends to areas like robotics. How so?
Well, researchers are using transformers to help robots understand natural language commands. Imagine a robot that can not only respond to pick up that box,
Right.
but can also understand more nuanced instructions like go to the kitchen and bring me something to drink that isn't water.
That's incredible. It's like we're giving robots a way to understand the world more like humans do through language.
Exactly. And transformers are also being used to help robots navigate complex environments and even learn new skills by watching videos. This could revolutionize how we interact with robots,
Wow.
making them more helpful and adaptable partners in all sorts of tasks.
What about the impact on creativity? AI is already generating art and music,
Right.
but with these new language models, it seems like the possibilities are limitless.
Absolutely.
Hmm.
Imagine AI collaborating with human artists, not just as tools, but as creative partners. Think about a musician working with an AI that understands their style and can help them compose a piece that pushes the boundaries of their genre.
Yeah.
Or a writer collaborating with an AI to brainstorm new plot twists or characters for their novel.
It's like giving artists a whole new set of tools and a partner that can truly understand their creative vision.
And don't forget, education transformers have the potential to create personalized learning experiences tailored to each student's needs. Imagine AI tutors that adapt to how you learn best,
Okay.
or systems that can translate complex scientific concepts into language that anyone can understand.
It's like democratizing knowledge, making it accessible to everyone regardless of their background.
These are just a few examples. The potential applications are vast, and we're only scratching the surface of what's possible. It's a truly exciting time to be witnessing these advancements unfold.
This deep dive has definitely given me a lot to think about. What's the one key takeaway you'd like our listener to walk away with?
I think the most important takeaway is that the way we think about and interact with AI is changing rapidly. The ability to understand and generate human language is at the core of this shift.
Right.
And the transformer, with its self-attention mechanism, has been a major catalyst. This field is evolving quickly, and it's going to continue to reshape our world in profound ways.
I couldn't agree more. Attention is all you need wasn't just a paper, it was a paradigm shift in AI. And as we've explored today, that shift continues to reverberate, opening up possibilities we could only have dreamed of just a few years ago. Thanks for joining us on this deep dive. Until next time, keep exploring, keep learning, and keep asking those big questions.